Yeah, here I am. Hi.
Oh, hey, welcome. So nice to have you online. Hope, yeah, your connection
Yeah,
is going to be
thanks for
stable
having me.
because you're casting from home in Germany, right?
In Austria, yeah.
Austria, I'm sorry. So,
Yeah.
yeah, I already introduced your talk. So it's going to be about the micro frontends using Webpack 5. I think, yeah,
Yeah.
without further much ado, I think we can start your talk.
Okay, cool. So you see my slides now, is that right?
Not yet.
Not yet.
Dario, is it? Yeah.
So that's a pity because they are shared using Zoom, as I've been told. So you don't see the slides, is that right? You can see it. Okay. Nice. Okay, great. So let's get started. Once again, thanks for having me. It's a pleasure to be here, and this talk will be about the micro front-end revolution with module federation and, of course, with Angular. And for this, I want to start with an image, with this one here. Do you remember this woman? Perhaps you have seen her several years or decades ago. Yeah, I give you a hint. It's yeah, right. She was from the Knight Rider team. She was Bunny. She was the engineer there. She created a lot of widgets and repaired them to help them succeed. And she really inspired me to make my parents to buy me a computer. I've told my parents, hey, it might be beneficial for school, which was not the case, of course. I mean, this was in the 80s. But I've got a computer and here I am nowadays. But when thinking back on Bonnie, one thing comes in mind that is somehow funny. Namely, it was a one man or let's say a one woman show. She was the only engineer on the team, the only electrical engineer, and the only computer scientist. And this does not work anymore nowadays because nowadays computer science and especially software engineering is a team sport. You need several people with a different skill set to succeed. And very often, you not only need just several people in one team, but you need several teams. And you have to coordinate all of them. And while coordinating people of one team is hard enough, coordinating several teams is even harder. And so we need some smart solutions for this. One smart solution is not to write a monolith which can do everything like a flight system, which allows you to check in into a flight, to buy tickets, to check in your luggage, and so on and so forth. No, we don't want to have this. Instead of this, we want to have tiny subsystems. Some people call them microservices in the backend for some years. So in this case, we had a booking service and a check-in service and a luggage service and a boarding service. With terms of domain-driven design, this would be called the subdomains. And now it's important to isolate those subdomains from each other. The lesser the domains know from each other, the better it is. If they know nothing at all from each other, it would be perfect because in this case, you could change something here without breaking something there. I think we all know this situation where we add a new feature and suddenly something else is broken. When we take this idea and put it to the front end, we get micro front ends. And the idea is the same. We have several tiny parts instead of one big monolith. And as mentioned, the big advantage here is we can assign one team to each of those subdomains, to each of those micro front ends, and they can work independently. They can work without interfering each other. They can work without blocking each other. They don't need to sit in meetings and do perhaps even political discussions. No, they can just provide business value in the sense of agility. So now the big question is how to implement micro frontends. And for this, we have several solutions. But as a matter of fact, so far there was not a perfect solution. So far, there have been a lot of workarounds and tricks using DOM manipulation, using custom tailored and handmade frameworks, but there was not an official solution. And this changes now. With Webpack 5 module federation, this all will change because now we have a feature for micro frontends baked into a base framework like Webpack itself. And this is what this talk is about. In this talk, I will show you two things. First of all, I will show you how to use module federation. And then I will show you a possible roadmap. There is not an official roadmap, but I will use my class here to predict a possible feature for you. Okay, before we get started, let me also introduce myself. I am Manfred. I'm a trainer for Angular and I'm also a consultant for Angular. I'm doing a lot of workshops and consultancy nowadays, mainly remotely because of the current situation. But when there is not a pandemic, I'm also like to work with other teams on site. I'm quite connected to the Angular team. I'm in the Google Developer Expert team and I'm a trusted collaborator. I'm always telling this little story that I always have to smile when I see that I'm a trusted collaborator, because we in German also have the word to collaborate, and it means the same, but always in a negative sense. To collaborate in German means teaming up with others. That's good. But in order to destroy something, and that's not that good. And if you look at my first pull requests, they have been about the German meaning of the word collaborating. Meanwhile, hopefully, I've reached the English meaning the Angular team for sure had in mind. Saying this, I'm doing a lot of stuff in the German-speaking area, but I'm also always happy if I can work together with companies around the globe, remotely or on site. Okay, so let's get started with the first chapter of this presentation with Webpack 5 and module federation. I'm always saying module federation is a bit like the 1980s. You have to experience them, otherwise you don't know what they are about, and that's why we are starting with a demonstration here. So in this demonstration, I have Zoom. No, I have not implemented Zoom. I have this application here. I have a shell application, and this shell application is capable of loading micro frontends like this here. The thing is, this micro frontend is a separately compiled, separately deployed frontend. It even runs in standalone mode, as you see here. And when we click on this button in the shell, newest version of this front end or a configured version. When we look at the network tab, then we see this looks a bit like lazy loading. So when I'm clicking on flights, I'm getting a bundle with the nice self-explaining name 798. And when I'm moving to the right, we see it only has 3.1 case. Only 3.1 case. This is nothing. And it's clearly that this micro frontend only contains its own code. It does not repeat the code for all the frameworks like Angular, React.js, NGRX, Bootstrap, and so on. No, there is only its own code involved. Because the frameworks like Angular, like NGRX, like RxJS is shared by the shell, which is also quite a nice feature module federation comes up with. Okay, perhaps you're saying now, hey, Manfred, that's nothing new, because that is lazy loading. And we have lazy loading since Angular 2, and even before it was possible with OC Lazy, this community project. And I'm saying now, yeah, it's a bit like lazy loading, but it's more than lazy loading, because if you look closely here, we have localhost 5000. And if you look closely there, we have localhost 3000. That means we are loading this micro frontend from a different origin. And this was not possible with lazy loading before, at least not with the Angular CLI and with Webpack. So in order to understand what's going on here, we need to answer one question, namely, how is it possible to load separately compiled code? And perhaps you are saying now, hey, Manfred, one more time, that cannot be that difficult, because we have dynamic imports, don't we? We have dynamic imports since ECMAScript 2017. And even before, we had the require keyword in CommonJS or in AMD-based bundles. So what's the deal here? I'm saying, yeah, that's right. But the thing is, Webpack, and so the Angular CLI, does not allow to point to a different origin, even with dynamic imports. And the reason for this is that Webpack assumes that everything is there at compile time. Everything needs to be there at compile time. Everything is compiled together, optimized together, and then it is split into chunks that can be lazy loaded. And because of this, because everything needs to be there upfront at compile time, this was not possible before, at least not without some tricks. Module federation, which comes with Webpack 5, will change this. In module federation, we have different roles. We have the host. In my case, the host is the shell. And we have the remote. In my case, the remote is the microfrontend. And now the host can map above. The host can map above, which is pointing to a different origin. Here I'm mapping the path mfe1 to the name mfe1, which is an alias. I'm saying, hey, everything that starts with the URL mfe1 points over there to the microfrontend, and over there it's also called mfe1. So you could use this for an alias. Perhaps it's called Manfred over there, and you want to call it Batman in the shell. Would be a nice example if you ask me. In this case, everything is mfe1. Please note that this does not say anything about the location of the microfrontend. For providing the location, there are several options. But we will talk about this later. So after we've mapped this path, we can use an exposer section over there within the microfrontend. This exposer section can expose parts of the application. Here I'm exposing this file, looks like an Ivy component under the name CMP. And so when importing something from mfe1, we are pointing over there. And when I'm proceeding with CMP, I'm getting this component out of the other application that might run in standalone mode over there. So it's really drop dev easy, isn't it? Angular itself does not notice anything here. It is just doing lazy loading, and Webpack underneath is doing the heavy lifting. Perhaps you wonder how to get the URL of the microfrontend in question. And as mentioned before, there are several options. I show you here the easiest option. When compiling the microfrontend, Webpack emits a remote entry point, which is just a tiny JavaScript file. Just a few bytes, telling the shell where to find the microfrontend. And then we can load the remote entry point into the shell. For instance, with a static script tag, we might also use the Webpack runtime API. This is then called dynamic module federation, or we could create this script tag in a dynamic fashion using DOM manipulation. There's even a way to put the location of the remote entry point into the Webpack config of the shell. It's a quite new option. Yeah, and after we've loaded this remote entry point, the Webpack runtime API knows where to find MFE1. So the next question is how to share libraries, because we don't want to load Angular itself 5 times if we have the shell and 5 or 4 microfrontends. So how can we avoid loading the same stuff time and again? And the answer is we can configure shared libraries on both sides. For instance, with the shared array here, which is the easiest option. There are more advanced options where you have to provide a full object with a lot of metadata telling Webpack how to share stuff. But in this example, I'm going with the array. And as you see here, I'm putting Angular core into this array on both sides. And that means that the shell is providing Angular core and the micro frontend is reusing it. If the micro frontend would not find Angular core as a shared library, it would load its own at runtime. This decision really happens at runtime because, the micro frontend cannot know upfront. And because of this, all the shared libraries are put into separate chunks, into separate bundles, so that they can be loaded on demand. So now the big question is, what is if the host shares a different version? Perhaps the host shares a wrong version. The host shares Angular 9 and the frontend is written for Angular 10, where in this case, we have 2 options. We can configure the micro frontend to load its own version. In this case, we had Angular 9 and Angular 10 side by side, or we can configure the host to use the shared version anyway. Perhaps it has not been developed for the shared version, but we can make it to use the shared version anyway. There are several options to configure this. And both might be fine in some cases, especially when we talk about tiny dependencies like Rx.js or underscore Lodash. But when it comes to your major framework, namely Angular, both might be bad. You don't want to use your micro frontend with the wrong version, and you don't want to load another version of Angular. And so, as both might be bad, you need to prevent this situation somehow by yourself, by introducing conventions, contracts. Even a mono repository can help, because the mono repository forces you into using one version, more or less. Of course, you can have different versions over time, but at one point in time, you have one versions of all your dependencies when you go with, let's say, an CLI or an X-based mono repo. Of course, each rule has an exception. Learner and so on have further possibilities to use several versions. But this is not what I'm referring here to. Also, you might go with integration testing, which means you can use an E2E test, an integration test in your staging environment, making sure that those parts of the system meeting each other for the first time at runtime feeds to each other. And another idea is to compare the version before deployment. Before you deploy your micro frontend, you look at the deployed shared versions, you look at your own versions, and you check if they fit together. If not, you have to postpone deployments, which one more time comes with some advantages and with disadvantages. Okay, cool. So much about this. Now let me show you how this all works. For this, dig a bit into the source code of this application here. So let's open the source code with Studio Code, for instance. And here I have the routes of my shell. And when you look at the routes of my shell, you see nothing special. From Angular's perspective, this is just a simple routing table using lazy loading. Lazy loading is even using the dynamic import. So from Angular's perspective, this is a simple traditional Angular application. But what Angular is not knowing is that MFE1 is mapped to a different origin, and that Webpack will load stuff from this different origin at runtime. So to map this, we have to look up the Webpack configuration. This simple Webpack configuration, and it contains this module federation plugin here. And this plugin tells us that we are mapping MFE1 to MFE1 over there. As mentioned before, we could now also mention the location of this other microfrontend, but I'm not doing this here within the configuration. It would be possible. And I'm defining my shared libraries. On the other side, if we look into the config of our microfrontend, we have the same module federation plugin. I'm assigning a name to it, MFE1. I'm defining the name of my remote entry point, and I'm exposing some stuff, a component and a module. Also, I'm telling Webpack I want to share this stuff with other microfrontends as well as with the shell. So this is everything we need. Of course, in this example, I'm using also Webpack for the rest of the compilation. But when we got a proper Webpack 5 support in the CLI, we could let the CLI create the Webpack configuration. And then everything we need to do is to tell the CLI to also use this section here with module federation. That means at the end of the day, you don't need to handwrite this whole Webpack config anymore. Okay, yeah, and so our shell can load the microfrontend on demand. There is just one thing lacking, namely we need to tell the shell where to find the remote entry point, where to find the other microfrontend. And for this, I'm going here with the simplest solution. I am referencing the remote entry points directly. I'm loading it when the shell starts up. Instead of this, I could use the Webpack low-level API. Most of the time, you will get to a helper function. This could look a bit like this here. Do it Webpack, of course. This is not the best name for it, but I think you've got the idea. There is a way to tell Webpack at runtime about all the microfrontends out there, about all the remotes. Okay, that's quite cool, isn't it? Because we do not need to change anything in the world of Angular. The change happens magically underneath. So perhaps you're saying now, hey, I really love this. I want to have it now. When can I have it? And the thing is, there is not an official roadmap. But if I look into my class sphere, I can predict the possible future. Namely, it's so that Webpack is currently in beta, and rumor says it will be out in late summer, perhaps early fall. And if this is the case, it comes early enough to be incorporated into the Angular CLI. The examples I've shown here are a proof of concept using a custom Webpack configuration, you've seen it, and a patched version of the CLI. Because, of course, the current stable version of the CLI is using the current stable version of Webpack, which is Webpack 4. And I assume you don't want to use a patched CLI version for production, and very likely you will not like to use a custom Webpack configuration for production. So the next version of the CLI is version 11, and it is due in fall 2020. In the last years, it was late November or early December. And yeah, if we are lucky, we get it together with Webpack 5 and the Webpack 5 integration. And everything we need then is a custom builder that is telling the CLI to use module federation, so that this tiny configuration section for module federation is squeezed into the CLI's Webpack config. But that's not a big deal, because we can already write custom builders today to adjust the behavior of the CLI. And a tool which is out there, which I have written several years before, is ngx build plus. ngx build plus is exactly doing this. It merges a partial Webpack config into the CLI's big Webpack config. So to put it in a nutshell, if we are lucky, we can have all of this in fall. Like this topic, you will very likely like my ebook too. You can download it here, it's for free, and it shows you several stuff about module federation, also advanced stuff and alternatives to module federation, and it shows you how to deal with domain-driven design, which is the methodological foundation for microfrontends. Okay, let me come to a conclusion. We've seen that the main purpose of all of this is scaling themes. When you remember the beginning of my presentation, we have to scale themes. And that means if you only have one theme, module federation, microfrontends might not be the right solution for you. You might not be able to reach the sweet spot because you don't gain much if you only have one theme, and you have to deal with a lot of other stuff like version conflicts. But if you have several themes, if you want to scale, this comes really in handy. This all is about decoupling your microfrontends so the themes can work independently. Module federation allows you to import stuff from other applications. We can share libraries, and please take care of conflicts. There are some solutions baked into module federation, but perhaps you need your own solutions, your own conventions, avoiding that Angular is loaded several times or avoiding that a wrong version of Angular is reused. And there is a last thing I want you to remember. Please try to be a bit like Bonnie. Bonnie was always thinking first. Instead of other people on this TV show, they have always been hitting first, but she was always thinking first. And in that sense, I want to encourage you to evaluate if you even need microfrontends. If you say, no, I don't need them because I only have one theme, we have no issue with scaling, then consider a monolith, a majestic monolith. I really like this term, majestic monolith, because the microfrontend and microservice people are saying, hey, a monolith is something that's bad. No, it does not need to be bad. It can be something beautiful, something majestic, if you take care about its architecture. And this most of the time involves linting rules, preventing that you break your own architecture. If you like this idea, look into NX. NX is a beautiful extension for the Angular theme allowing this. And if you say, yes, I need microfrontends because I need to scale or I need, let's say, a plug-in system, then consider module federation. If you ask me, module federation is a very, very attractive take on the topic of microfrontends. Perhaps the most attractive one so far. Okay, so thanks for having me. Here you have all my contact data. Feel free to reach out to me if you need anything. I've also uploaded my slides to my blog. And if you want, follow me on Twitter so that we can keep in contact. Thank you.
Oh, thank you, Manfred. Awesome talk. Really expert, in-depth explanation of the microfrontends. We have a lot of questions on our feed, and I also have a couple of my own. So yeah, since we are we have an abundance of time, we're gonna keep the Q&A session right here on the main stage. So
Nice.
To start, let me ask something Jung Bubai wrote. He wrote it early in your talk. He said, I'm very curious about the microfrontends. I'm not sure Manfred will cover this topic today, so let us know if you did cover it. If microfrontends need to communicate with each other, how do we do that? I want to know how to communicate with each microfrontend in customer browser. what is the best way to communicate each other in the browser at runtime?
Yeah, it's a good question. And this question leads to a funny answer because on the one side, we want to have isolated micro frontends that do not know much about each other. And on the other side, we want to have communication, which is breaking the isolation because we are communicating. So this creates coupling. And this one more time shows that software architecture is about trade-offs. We have to find the right sweet spot that works for us. And in turn, it means we cannot have both, at least not fully of both of them. But if you ask me how to communicate, one answer would be when we go with module federation, we could just go with a shared service, a shared Angular service. I would call this service message bus. Perhaps it only provides a behavior subject I can use to expose messages. Messaging is a very unobtrusive way of communicating because I don't assume an answer. I'm sending out a message. I'm notifying the world about an event. And if everyone is interested about it, it's fine. If no one is interested about it, it's even fine. So it's very unobtrusive. And so this is lowering coupling.
All
So
right.
if it's possible, I would try to use some messaging mechanism like a behavior subject.
In a shared service.
Yeah.
I'm glad you mentioned trade-offs during your answer, because I tuned in for your conclusions, and I saw that you said the main purpose of microfrontends is scaling teams. So so then it's organizational concerns above all else. So since there are always trade-offs in software engineering, what do you think? To what extent does that compromise good engineering and good software building, prioritizing team scaling? What's your opinion on that?
I'm not sure if it's about compromising, but I'm sure that you need to know your architectural goals. And if your architectural goal is that you need to share stuff and that you need to scale your teams because the application is that huge, then micro frontends are fine. If your architectural goals are not about scaling teams, but totally about slim bundles, totally about, let's say, a unique UI, then perhaps it's not the right for you. But I would not go that far to say that there is something like the one and only best practice we need to achieve. It's always about your very own goals, and they are project specific.
All right. So let's continue with the next question we had in chat. This one was from Jonathan de Vries. He says, I'm also interested in how communication between microfrontends would work. Oh yeah, that was already addressed by a previous question. That was good. So the next question was from Leodargio Pasakadal. He asked how the states will be managed across the submodules.
So the thing is, I would not share much state. Most of the time, it is okay if you just share a tiny amount of context information, like who is the current user, who is the current customer, for which quarter we are doing now an invoice or something else. I would not share much because if you share much state, you have this high coupling, and so you will very likely not reach the sweet spot I've talked about. That's why I am also not using the Redux store for communication. I'm using a simple message service like a shared Angular service with a behavior subject.
Okay. So next question. It's from Genk Blakori. He asked, is it possible for a module to be a shell and a remote front-end app at the same time?
Yeah, that's totally possible. In my example, for the sake of simplicity, I had two roles and two applications for each of those roles. But in real world, one application can have both roles at the same time.
Okay, the next question is from Agan Hassani. He's asking, what are the drawbacks of this architecture, if any, except keeping the same Angular version between the shell and Microfrontends? So yeah, what are the drawbacks?
The drawbacks. Well, I think that versioning is the biggest challenge. There are some other things you need to keep in mind. Let's say you have two or several teams. In this case, those teams have to make sure that they are using a common look and feel. Otherwise, one team would have another UX than the other team. And this might be bad. One more time, it really depends upon your architectural goals. But when it is a shop application, a B2C application, a consistent look and feel might be more important. If it is an ERP system, then it might not be that important that the, let's say, accounting part has exactly the same look and feel as the payroll. It would be nice, but very likely there are different people working with these two parts of the application, so it is not that important. This is one thing. We have also some challenges with sharing widgets, because sometimes we want to share widgets to avoid duplicated code. On the other side, every time we share a widget, we create a contract. And that means that our applications are not that isolated as they should be. It's one more time about finding the sweet spot.
Mm-hmm. Yeah. So I scrolled through the chat, so I see there are a lot more questions coming in while we were talking. I hope I'm not missing anything. So I think the next question was asked was, what's the difference to importing bundled web components? Is it about getting rid of the multiple Angular core import, right?
Can you repeat the question, please?
Yeah. What is the difference to importing bundled web components? Is it about getting rid of the multiple Angular core imports?
Yeah, absolutely. Absolutely. Mm-hmm. Of course, you can already today compile your several microfrontends into different bundles. You can compile it using Angular elements to web components, or you can compile it to traditional single-page applications. And then you can already today load these bundles dynamically with some DOM manipulation in a shell and show and hide the different single-page applications. But in this case, you have versions of Angular, which might decrease the user experience because they need to download